This is Mr. Beck Does Your Homework, AP Physics, Homework 8.3, questions 3 and 4. It says a 6.29 liter vessel, well, let me see, that's the volume is 6.29 liters, I'm going to have to convert that, contains nitrogen gas, I don't think I care that it's nitrogen, at a temperature of 28.7 degrees Celsius. Well, my temperature usually has to be in Kelvin, so I'm going to think about that, 28.7 degrees Celsius. And a pressure of 5.38 atmospheres. Well, I'm used to using pascals, but I'm going to write 5.38 atmospheres for a second here. Boltzmann constant is, what is the total translation energy of the gas? Total energy of the gas, that's my internal energy. I know that my internal energy is 3/2 of N times Boltzmann's constant times the temperature. That's because the kinetic energy of a single atom on average, or a single particle on average, is 3/2 of Boltzmann's constant times the temperature. But if I want all of them, I have to multiply by the number of moles, sorry, the number of molecules. So each atom times how many atoms gives me my total energy. Now this, NKBT, also reminds me that PV equals NKBT, just as PV also equals little n big R, nRT. There's Pivnert, PV equals nRT. So if U is 3/2 NKBT, I can replace this with this and say that my U is 3/2 of P times V. Now, this is going to be pretty easy. So there's my total translational kinetic energy. That's my U. 3/2 of P, my pressure, times V, my volume. Well, volume is 6.29 liters. I know that there are 1,000 liters in a cubic meter. So this becomes 0.00629 cubic meters. And my volume is, sorry, that's my volume. My pressure is 5.38 atmospheres. Well, I'm going to have to multiply that by 101,300 because that's how many pascals are in each atmosphere. So that's going to give me my pressure. So now I've got 3/2 times my pressure times my volume. Well, that's 3/2 times my pressure times my volume, and I'll get my U. So that will be my answer to number 3. Number 4 says, what is the average kinetic energy per particle? Well, I could use this relationship. If I knew how many particles there were, then I could do just take U and divide it by the number of particles. But I don't know that. But I do know Boltzmann's constant, and I do know the temperature. Well, the temperature, 28.7 Celsius. If I add 273 to that, I'm going to get my Kelvin temperature. There's my Kelvin temperature. So my average kinetic energy for one molecule is simply going to be my 3/2 times my Boltzmann's constant times that temperature that I figure out up here. So 3/2 kb times T, and that will give me my average kinetic energy per particle, per molecule, and that will give me joules.